10.1. So in Notes 10.1, we are continuing to solve quadratics by factoring, but we're going to take it one step further. I do want you to complete your warm-up on your own. Okay, try your warm-up on your own. Remember, where should your notes be going? In your Algebra 1 folder. Remember, you are going to use that box method. Okay, and we're going to talk more about the box method here in a second because that's still the method that we're going to use to factor. Let's take a look at this example 1 though. So in example 1 it says, what are the solutions to the equation? What it's asking for is the zeros. And when I say zeros, what do I mean? We've talked about this before. The zeros are the x values. So when it says solutions, you can think about it as the zeros or the x values. Okay? So like I said, we're still using that box method, so I'm going to go ahead and create my box. Okay, it does not have to be perfect. Remember, Miss Bailey's iPad thankfully makes a nice little square for her, but your square does not have to be perfect. But I should be seeing a square on your notes because that is the method you're going to use on the STAR test. So you're going to take this leading coefficient. You know that's what's supposed to be in box number 1. You're going to take this constant and you're going to put that in your last box. Okay? And you know that you need something that's going to multiply to get x squared. So what would that be? Well, x times x gets me x squared. Remember, you're just filling out the riddle now. We're trying to solve this entire box. So let's keep filling out our box, our riddle. Okay, I know that that gets me x squared. Now here's where it gets a little bit different because I want these two boxes to add to get -8. Right, so I'm going to write that down. I want something that adds to get -8. And I need something that multiplies to get 12. Okay. So you might have to try a few different things out. Like I know that 4 and 4, -4 and -4 will add to -8, but will it multiply to get 12? It won't, so that won't work. Let's think about something else. I know that 1 and -8 could add to -8, but would it multiply to 12? No, so let's try something else. What about 6 and 2? -6 and -2. Will -6 and -2 add to get -8? Definitely. But will it multiply to get 12? Yeah, it will. So -6 and -2 work. -6 and -2. And then I keep filling out my box. I know that -6 times x is -6x. I know that -2 times x is -2x. And you could even factor backwards, right? And figure out that, oh, well, -2, -6 could be -8. And then that's my entire trinomial. So you know that your first factor is x minus 6. And your second one is x minus 2, which is perfect, right? That's exactly what we did with Unit 9. But now we're going to take it one step further because we want the solutions. So now you're solving this for x. Because remember, what do I want? I want my zeros, my x values. So you're solving for x, which means you're going to set it up just like this. You're going to say x minus 6 is equal to 0. And another one, because we have two of them here. X minus 2 is equal to 0. Okay? Well, remember, I'm just trying to get x completely alone, so I'm just going to go ahead and get rid of that friend off to the side. Remember, you can split it down if you want to. Plus 6, that leaves me with x is equal to 6. Is x completely alone right there? It is. So that works. Plus 2, because I have to do the opposite, right? If it's being subtracted, the opposite would be to add it, to get rid of it. Cancels that out. X is equal to 2. Now, that means your solutions, your zeros, your x values are x equals 6 and x equals 2. And you can even check this using our best friend, Desmos, right? And how do we do that? How do we check to see? Well, by doing y is equal to, and then I'm going to put in that trinomial. I'm going to put what's on the left side of that equal sign. So I'm going to say x squared minus 8x plus 12. Okay? So now I just need to check where my zeros are. What did we say our zeros were? The x values. So I'm going to click right here on my x value, and I have an x at 2 and I have an x at 6. Is that what we said? X equals 6, x equals 2? It is. So you can check your answers using Desmos, right? Remember, Desmos is our best friend. We need to use Desmos when we can because that's what we're going to use on the STAR test. You are going to try example 2 on your own. Remember, I should be seeing that box method. All right. What is a solution or solution set in a quadratic? Remember, we said it was our x value zeros. The solution to a quadratic is where the graph crosses the x-axis, also known as the, here's another word, roots. So we're looking for roots or zeros or x values. Okay, remember that is what we're looking for here. All right, let's take a look at example 3. Okay, now example 3. Same thing. I'm going to use the box method. But this one's a little bit different. Can you tell me why this one's a little bit different? What is different about it? That leading coefficient is not 1, it's 6, right? So that changes things a little bit. I still know that this needs to be 6x squared, okay? And I still know that this needs to be 1. That's still true. But now, instead of trying to do this 5 here, what we're doing is we're taking this 6, this leading coefficient, and we're multiplying it by that constant. And that's what we need to multiply to. So remember, you can use the x, and we want to know what multiplies to the coefficient times the constant, so 6. But adds, still trying to add to this right here, 5. So think about some things that would multiply to 6 and add to 5. You don't have a lot of options, right? I know that 1 times 6 gets me 6, but will that add to 5? No. But what about 3 and 2? It will, right? 3 times 2 is 6. 3 plus 2 is 5. Because remember, we're multiplying to get this, adding to get this. But this time it's a little bit different because I'm going to take those two numbers and I'm going to put them in here. So I'm going to say 2x and 3x. And now I am solving the riddle by figuring out what multiplied together to get each of these. So here, I know again 1 times 6 would give me 6x, but I wouldn't have got 3, right? So once again, I would probably do 3x and 2x, because 2x and 3x give me 6x squared. Okay, but what times 3x would get me 3x? Well, anything times 1 gets you itself. Same thing here. What times 2x would get me 2x? 1. So you have your two factors. You have 3x plus 1. You have 2x plus 1. But remember, I'm not done there because I'm looking for my solutions or my roots, zeros, x values. So I'm going to solve for x. So 3x plus 1 is equal to 0. Is it easier if I'm trying to get x completely alone? I am trying to go on a date with x. I want them completely by themselves so I can get all of their attention. Is it going to be easier to get rid of the person they're attached to or the friend off to the side? The friend off to the side, right? So get rid of that first. Minus 1 here, minus 1 here, because I have to do the opposite. So cancels that out, leaves me with 3x is equal to negative 1. Is x alone yet though? Can I go on a date with them? I can't because they're still attached to 3. How do I get rid of 3? What is the opposite of what's happening there? Divide. Canceling that out, leaving me with x is equal to negative 1 over 3 because I can't simplify that at all. And then I would do the same thing on this side. So 2x plus 1, and you can probably see where this is kind of going because it's almost the exact same method. 2x is equal to negative 1. There we go. Divide by 2, divide by 2. X is equal to negative 1 over 2, and I can't simplify any further. So these are my x values, roots, zeros. Okay? And I can check that with my best friend Desmos, but it's a little bit different because this one says 6x squared plus 5x plus 1. It's a little different, but let's try it and see if it works. So we're going to say y equals, and we're going to put it in exactly how we see it, 6x squared plus 5x plus 1. Okay, now this is different. I have negative 1/2. I'm sorry, negative half, not 1/2. Perfect. Okay, and then I have negative 0.33333, which I will tell you is negative 1 over 3. So there you go. You figured it out, and you proved it by using Desmos. You are going to try example 4 on your own. Remember, you're still using box method. Do not let all of these words scare you. It says the area of the rectangular trampoline is 60 feet squared. Okay, 60 square feet. The length of the trampoline is 11 feet less than the width of the trampoline. This situation can be represented by, so look, you don't even have to come up with the equation, it gave it to you. And then what do we do with these trinomials? What method should we use? The box method. And then it's the same exact process. Don't let it scare you just because it adds a lot of words in it. Still the same process. Try this example 4 on your own. And then last but not least, example 5. You are going to solve this on your own as well by using the box method. Okay? But it says to also complete the statement. So when it says the zeros are blank and blank, remember your zeros are your x values, your solution. So if I was filling the statement out for this one, I would say my zeros are negative 1 over 3, negative 1 over 2. Then it says because the factors of g are blank and blank. Well, remember the factors is what you get when you do the box method. All right. Remember, you are doing number 2, number 4, and number 5 on your own. Let me know if you need any help. I'll see you for notes 10.2.